I'm so glad you found your way here, right now. As you listen to these words, your brain is already preparing for the dreams that await you tonight. You'll discover why we dream the way we do and understand how your sleeping mind creates entire worlds from within. Welcome to Sleepy Science Facts. Wherever you are right now, perhaps feeling the gentle weight of blankets settling around you, or simply allowing your thoughts to slow after a long day, let yourself rest in this quiet moment. We'll journey through 100 psychology facts about the science of dreams, from the electrical storms that paint your nighttime visions, to the memories that weave through sleep, to the emotions that find healing in darkness. This thoughtful journey through the dreaming mind builds bridges between searching souls seeking peaceful rest. A soft like or sharing your thoughts creates a pathway for more curious minds to discover this sanctuary of calm, one sleepy soul at a time. Your presence here inspires ours. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness, thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace, and now we begin. Based on research estimates, you spend approximately 6 years of your life dreaming, assuming roughly 2 hours of REM sleep each night across an average lifespan. Every night, whether you remember or not, your brain generates multiple dreams across several sleep cycles. Most people experience 4 to 6 distinct dreams per night, though the vast majority slip away upon waking. This means that by the time you reach old age, you will have spent over 2,000 days in dream states, experiencing countless adventures, emotions, and visions that exist only within the theatre of your sleeping mind. Dreams are not rare events. They are a constant companion, present every single night, whether we acknowledge them or not. The dreaming brain never truly rests from its creative work. Dreams occur primarily during a sleep stage called REM, which stands for rapid eye movement. During this phase, your eyes move gently back and forth beneath closed lids, as if watching invisible scenes unfold in slow motion. Your brain becomes remarkably active, showing patterns similar to wakefulness on brain scans, yet your body remains mostly paralyzed, a protective mechanism that prevents you from acting out your dreams. This paralysis, called atonia, keeps you safely in bed while your mind soars through impossible landscapes. REM sleep cycles occur roughly every 90 minutes throughout the night, with each REM period growing longer as morning approaches. Your longest and most vivid dreams typically occur in the final hours before waking. The prefrontal cortex, the part of your brain responsible for logic and critical thinking, becomes remarkably quiet during REM sleep. This region normally helps you distinguish reality from imagination, evaluate whether situations make sense, and plan careful actions. When it goes partially offline during dreaming, you lose the ability to question strange events. This explains why you can fly through clouds, breathe underwater, or encounter deceased loved ones without ever questioning the impossibility. In dreams, pink elephants seem perfectly reasonable. Time can flow backward. You might attend meetings in your pajamas without feeling alarmed. The sleeping brain accepts whatever story unfolds, no matter how bizarre, because the reality-checking systems have temporarily stepped aside. While your logical brain rests, your emotional centers become highly active during REM sleep. The amygdala, a small almond-shaped structure deep within your brain that processes emotions, shows increased activity during dreaming. This explains why dreams often carry such intense emotional weight. Fear in nightmares feels genuinely frightening. Joy in pleasant dreams creates real happiness. Grief over dream losses produces actual tears. These emotions are not simulations. They are authentic experiences generated by the same brain regions that create emotions during waking life. The sleeping brain feels just as deeply as the waking brain, sometimes even more so, because the logical filters that usually moderate emotional responses have temporarily dimmed. The hippocampus, your brain's memory center, plays a fascinating role in dreaming. This curved structure, named after the Greek word for seahorse due to its shape, helps convert short-term memories into long-term storage. During sleep, the hippocampus replays recent experiences, sending information to other brain regions for permanent storage. However, the hippocampus doesn't store dream experiences themselves very effectively. This is why dreams fade so quickly upon waking. Your brain treats dream events as temporary experiences, not meant for permanent recording. Unless you wake during or immediately after a dream and consciously rehearse its contents, the memory dissolves like morning mist, leaving only fragments or nothing at all. Recent research suggests that dreams may help process emotional experiences and reduce their intensity over time. When you experience something stressful or emotionally charged during the day, your brain may replay these events during REM sleep, but in a chemically different environment. Stress hormones like norepinephrine are at their lowest during REM sleep, allowing you to revisit difficult memories without the full physiological stress response. This process may help strip away the emotional intensity from troubling memories, allowing you to remember events without being overwhelmed by the feelings originally attached to them. Dreams might serve as a gentle form of overnight therapy. Not all dreams occur during REM sleep. Researchers have discovered that dreams can emerge from any sleep stage, though they differ in quality. REM dreams tend to be vivid, bizarre, and story-like, full of strange characters and impossible scenarios. Dreams from non-REM sleep stages are often more mundane, resembling thoughts or vague impressions rather than elaborate narratives. You might dream of doing laundry or having a simple conversation during light sleep. These simpler dreams occur throughout the night but are easily forgotten. The dramatic, memorable dreams that we typically think of as dreams usually emerge from REM periods, particularly those in the second half of the night. Your brain paralyzes your muscles during REM sleep to prevent you from acting out your dreams. This protective mechanism is controlled by specific neurons in the brainstem that actively inhibit motor signals to your voluntary muscles. In some people, this system malfunctions, resulting in a condition called REM sleep behavior disorder. Those affected physically move during their dreams, sometimes with surprising energy. Because their bodies are not properly immobilized, they may punch, kick, or leap from bed while still asleep. This condition reveals something remarkable about dreams. The brain generates real motor commands during dreaming. You actually intend to run, to reach, to speak. Only the paralysis system prevents these intentions from becoming actions. The content of dreams often reflects concerns from waking life, a phenomenon researchers call the continuity hypothesis. If you spend your days worried about an upcoming presentation, you might dream about public speaking or being unprepared. If you're learning a new skill, you might dream of practicing it. Studies have shown that people often incorporate recent experiences into their dreams, though usually in transformed or fragmented ways. Dreams rarely replay events exactly as they happened. Instead, they remix elements, combining recent memories with older ones, creating scenarios that feel both familiar and strange. Your waking concerns don't disappear at night. They simply take on new and unexpected forms. So yes, understanding why we dream the way we do begins with recognizing that dreams emerge from a unique neurological state. Your brain is highly active, your emotions are amplified, your logic is dimmed, and your body is safely immobilized. This creates the perfect conditions for experiences that feel absolutely real in the moment yet dissolve like smoke upon waking. The dreaming brain is not malfunctioning. It is operating in a special mode, processing information and emotions in ways that waking consciousness cannot. Every strange dream makes perfect sense when you understand the sleeping brain's unique operating system. Scientists can now predict certain aspects of dream content by monitoring brain activity during sleep. Using sophisticated brain imaging techniques, researchers have identified patterns of neural activity that correspond to specific visual elements in dreams. When participants dream of faces, the brain regions responsible for face recognition become active. When they dream of places, spatial processing areas light up. This remarkable finding suggests that dreams are not random noise but structured experiences generated by the same neural systems that process real-world perceptions. Your dreaming brain uses its visual, auditory, and spatial processing systems to construct experiences that feel genuinely real because they activate the same circuits as waking perception. Dreams may play a role in creative problem-solving. Throughout history, artists and scientists have reported breakthrough insights arriving during dreams. The brain's loosened associations during REM sleep may allow novel connections between ideas that would seem unrelated during waking thought. Recent research suggests that people who briefly enter the earlier stage of sleep, called hypnagogia, may show enhanced creative performance afterward. This twilight state between waking and sleeping appears to be particularly fertile ground for creative insights. The sleeping brain explores possibilities that the waking mind, with its logical constraints, might never consider. Sometimes the answer to a problem arrives not through deliberate thought, but through the wandering pathways of a dream. Children's dreams differ significantly from adult dreams. Young children often dream in static images rather than narratives, and their dream characters may not include themselves until around age 7 or 8. As cognitive abilities develop during childhood, dreams become more complex, more story-like, and more self-aware. The development of dreaming parallels the development of waking cognition. Children who have more advanced cognitive skills when awake tend to have more elaborate dreams. This suggests that dreaming requires certain mental capacities to develop first. Dreams are not simply random. They reflect the dreamer's level of cognitive and emotional development. Certain themes appear repeatedly in dreams across cultures and throughout history. Falling, flying, being chased, appearing naked in public, teeth falling out, being late or unprepared, and losing loved ones emerge in dream reports from around the world. These universal themes suggest that dreams tap into shared human experiences and concerns, rather than being entirely random. The fear of falling may connect to our evolutionary past when sleeping in trees made falling a genuine danger. Being chased reflects the ancient reality of predators. These common dream themes reveal something about our shared human nature, the fears and concerns that unite us across time and place. Flying dreams are among the most common positive dream experiences reported across cultures. In these dreams, people soar through air, sometimes by swimming motions, sometimes by simply willing themselves upward. The sensation often carries feelings of freedom, joy, and exhilaration. Researchers believe flying dreams may represent feelings of empowerment or a desire to escape constraints in waking life. The specific method of flying and the emotional tone of the dream may reflect the dreamer's psychological state. Some people experience flying dreams as liberating, others find them frightening. The dream itself is universal, but its meaning varies with the dreamer's life circumstances and emotional landscape. Nightmares serve a different purpose than pleasant dreams, though researchers still debate their exact function. One theory suggests that nightmares help us process fears and prepare for threats by allowing us to practice emotional responses in a safe environment. Another theory proposes that nightmares occur when the emotional processing of dreams encounters intensity that takes time to integrate smoothly. Frequent nightmares are associated with anxiety, stress, and trauma in waking life. The brain may be attempting to process difficult experiences but struggling to do so effectively. Treatment approaches that help people rewrite their nightmare scripts have shown success in reducing nightmare frequency. Lucid dreaming occurs when you become aware that you are dreaming while still within the dream. This remarkable state blends the immersive experience of dreaming with the self-awareness of waking consciousness. During lucid dreams, some people can even control dream events, choosing where to go and what to do. Brain scans of lucid dreamers show increased activity in the prefrontal cortex, the same region that normally goes quiet during regular dreams. This reactivation of logical, self-aware brain regions appears to enable the recognition that the current experience is a dream. Lucid dreaming can be learned, though it requires practice and patience for most people. The discovery of REM sleep in 1953 marked a turning point in dream research. Before this discovery, scientists could not easily identify when dreams were occurring. Researchers Eugene Asarinsky and Nathaniel Kleitman noticed that sleeping subjects showed periodic bursts of rapid eye movements throughout the night. When awakened during these periods, subjects almost always reported vivid dreams. This finding gave scientists a window into the dreaming brain, allowing them to study when dreams occur, how long they last, and what happens in the brain during these remarkable experiences. The science of dreams, once relegated to speculation, could finally be investigated with precision. Your dream recall varies depending on when and how you wake. If you wake during or immediately after REM sleep, you're much more likely to remember your dreams than if you wake from deep, dreamless sleep. The alarm clock that jolts you awake may be stealing your dreams by interrupting the natural waking process. People who wake gradually and lie still for a few moments, allowing memories to consolidate, tend to recall more dreams. Keeping a dream journal beside your bed and writing immediately upon waking can dramatically improve dream recall over time. The memories are there. They simply need to be captured before they fade. Dreams often incorporate sensory information from the sleeping environment. A doorbell in real life might become a ringing phone in a dream. Temperature changes in the room might manifest as dream weather. The sleeping brain monitors the external world and weaves relevant information into the ongoing dream narrative. This incorporation usually happens seamlessly, maintaining the dream's internal logic while responding to external stimuli. Researchers have used this phenomenon to study dreams, presenting sounds or smells to sleeping subjects and examining how these stimuli appear in subsequent dream reports. The dreaming mind is not completely isolated from the waking world. Sleep deprivation affects dreaming in profound ways. When people are deprived of sleep and then allowed to sleep normally, they show a phenomenon called REM rebound, spending more time than usual in REM sleep. This suggests that REM sleep, and perhaps dreaming, serves important functions that the brain prioritizes when given the opportunity. People who experience severe sleep deprivation sometimes report dream-like hallucinations while awake, as if the pressure to dream becomes so strong that it breaks through into waking consciousness. The brain seems to need its dream time and will find ways to claim it if denied too long. Medications can dramatically alter dream experiences. Certain antidepressants suppress REM sleep and reduce dream recall. Other medications, particularly those affecting dopamine or acetylcholine, can intensify dreams or trigger nightmares. People withdrawing from REM suppressing medications often experience intense, vivid dreams as the brain rebounds into increased REM sleep. Even common substances like alcohol affect dreams. Alcohol initially suppresses REM sleep, but as it metabolizes during the night, REM sleep increases, often producing strange or disturbing dreams in the early morning hours. The chemistry of your brain directly shapes the character of your dreams. Blind people dream differently depending on when they lost their sight. Those blind from birth dream primarily in other senses, experiencing sounds, touches, tastes, and smells without visual imagery. Those who became blind later in life often continue to dream in visual images, particularly of places and people they knew before losing sight. As years pass, visual elements may gradually fade from dreams. This finding reveals that dream imagery depends on the brain's experience with that sensory modality. The visual cortex needs visual experience during development to generate visual dreams. Dreams are built from the raw materials that experience provides. Animals almost certainly dream. Researchers have observed REM sleep in all mammals studied and in birds, while earlier research found no REM in reptiles or fish. Recent studies have discovered REM-like sleep in certain reptile species, suggesting this sleep state may be more ancient than previously thought. During REM sleep, animals show muscle twitches, eye movements, and brain patterns similar to humans. Cats with damage to the brain region that causes REM paralysis act out what appear to be hunting behaviors during sleep. Rats show replay of neural patterns associated with maze running while they sleep after learning new mazes. The sleeping brains of animals seem to process experiences much as human brains do. Your cat curled beside you is likely dreaming its own feline adventures. The emotional tone of dreams typically shifts across the night. Early night dreams often deal with recent practical concerns and tend to be more neutral or negative in tone. Later night dreams, occurring in longer REM periods, become more intense, more bizarre, and often more positive. Morning dreams are when the most vivid story-like experiences typically occur. This shift may relate to the brain's changing chemistry across the night, as stress hormones decline and other neurotransmitters fluctuate. The dreams that greet you just before waking may be the most elaborate productions your sleeping mind creates, full orchestras playing in the final movement before the curtain rises on another day. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside, trillions of organisms working in silence, heart beating, lungs breathing, brain thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You're a complete ecosystem, diverse, self-balancing. Even now, as you rest, your brain is preparing the dreams that await you. The same neurons that create your waking thoughts are quietly organizing the visions of your sleep. Trust this process. It has sustained you every night of your life. Now we continue. Dreams rarely replay memories exactly as they occurred. Instead, the sleeping brain recombines memory elements in novel ways. You might dream of your childhood home but populated with co-workers from your current job. A conversation from yesterday might unfold in a location you visited years ago. This creative recombination may serve memory consolidation, strengthening connections between related memories and integrating new information with existing knowledge. The strange juxtapositions of dreams are not errors, but features of a system designed to find connections, to weave new experiences into the fabric of everything you already know. The visual cortex, the brain region that processes sight, remains highly active during REM sleep, even though your eyes are closed and receiving no visual input. This internal activation generates the visual experiences of dreams. Brain imaging studies show that specific visual areas activate in patterns that correspond to reported dream content. When dreamers report seeing motion processing areas light up. When they report seeing colors processing areas activate. Dreams are constructed using the same neural machinery that builds your perception of the waking world. This is why dream experiences can feel so vividly real. Dreams may help regulate mood and emotional balance. Studies have shown that people deprived specifically of REM sleep show increased irritability, anxiety, and difficulty with emotional regulation. The REM sleep they miss is recovered in subsequent nights through increased dreaming. This suggests that dreaming serves important emotional functions that the brain prioritizes. One theory proposes that REM sleep provides a time for emotional memories to be processed and their intensity reduced. Another suggests that dreams allow us to rehearse emotional responses in a safe environment. Whatever the mechanism, dreaming appears closely linked to emotional well-being. Some researchers believe that dreams serve no function at all, representing merely the brain's attempt to make sense of random neural activity during sleep. This activation synthesis hypothesis suggests that dreams are stories the brain constructs to explain strange internal signals, much as we create narratives to explain events in waking life. According to this view, dreams have no inherent meaning beyond the brain's tendency to find patterns and create narratives. Other researchers strongly disagree, pointing to evidence that dreams serve memory consolidation, emotional processing, and other important functions. The debate continues in sleep laboratories around the world. People who study dreams intensively often begin remembering more dreams. This increased recall likely reflects heightened attention rather than increased dreaming. When you care about your dreams, you're more likely to notice them upon waking and more motivated to hold on to the fading memories. Dream recall can be trained like any skill. Those who keep dream journals often report remembering multiple dreams per night after just a few weeks of practice. The dreams were always there, occurring every night throughout your life. Only your awareness of them has changed. The content of dreams shifts across the lifespan. Young adults often dream about romantic relationships, social situations, and achievement. Middle-aged people more frequently dream about family, work, and health concerns. Older adults tend to dream about the past, about deceased loved ones, and about life transitions. Dreams reflect the concerns and experiences of each life stage, changing as priorities and preoccupations shift. The dreaming mind remains engaged with whatever matters most at any given time, processing the particular challenges and joys of each chapter of life. Recurring dreams affect roughly 2/3 of adults at some point in their lives. These repetitive dreams often involve themes of being chased, falling, or facing some threatening situation repeatedly. Researchers believe recurring dreams may reflect unresolved concerns or ongoing stresses in waking life. The dream persists because the underlying issue persists. Some people report that recurring dreams finally stop after they address the waking life concern that seemed connected to the dream. Others find relief through dream rehearsal techniques that consciously rewrite the dream's ending while awake. Dreams during pregnancy often become more vivid and easier to recall. This may result from hormonal changes, altered sleep patterns, or the emotional intensity of expecting a child. Many pregnant people report dreams about babies, about the process of birth, or about their changing identity as they prepare for parenthood. These dreams seem to process the psychological work of this major life transition. Dream themes often shift across the 3 trimesters, following the changing concerns of each stage of pregnancy. The sleeping mind keeps pace with the profound changes happening in body and life. Post-traumatic stress disorder often manifests in dreams as nightmares that replay or symbolize the traumatic event. These trauma nightmares differ from ordinary bad dreams in their intensity, their tendency to wake the sleeper, and their resistance to normal processing. The normal dream system that helps regulate emotions becomes overwhelmed by experiences too intense to integrate. Effective treatments for trauma often address nightmares directly. Techniques that allow people to consciously rewrite their nightmares while awake have shown remarkable success in reducing nightmare frequency and improving overall sleep quality. The default mode network, a collection of brain regions active during mind-wandering and daydreaming, shows significant activation during REM sleep. This network seems to support internal mental activity when attention is not focused on the external world. Its activation during dreaming suggests a continuity between waking mind wandering and sleeping dreams. Both involve internally generated experiences, narratives constructed without external input. Daydreams and night dreams may share more in common than their different names suggest. Both emerge when the mind turns inward, freed from the demands of processing the external environment. Time in dreams does not always match real time. Some researchers have found that certain dream events unfold in roughly real time, while others seem compressed or expanded. 5 minutes of dream time might correspond to varying amounts of actual time depending on the nature of the dream activity. The perception of time within dreams remains somewhat mysterious. Sometimes dreams feel like they last hours when only minutes have passed. Other times, elaborate narratives seem to compress into moments. The sleeping brain has its own relationship with time, unconstrained by clocks and schedules. Dreams incorporate sensory modalities beyond vision, though sight dominates most dream reports. People commonly experience sounds, touch sensations, and movement in dreams. Smell and taste appear less frequently, but are reported by many dreamers. The intensity and presence of different senses varies across individuals and across dreams. Some people experience predominantly visual dreams with little other sensory input. Others have rich multisensory experiences. The sleeping brain can generate any sensation it has learned to perceive, creating experiences that engage multiple senses simultaneously. Cultural beliefs about dreams shape how people remember and interpret their dream experiences. Some cultures view dreams as messages from ancestors or spirits, treating them with great significance. Others see dreams as meaningless mental static, unworthy of attention. These cultural frameworks influence what people remember about their dreams and how they relate those memories. Dream content itself may even be shaped by cultural expectations. People dream of whatever their culture has taught them dreams might contain. The sleeping mind draws from the full library of cultural knowledge and belief. Sleep spindles, brief bursts of brain activity during light sleep, appear related to memory consolidation and may influence dream content. These electrical signatures increase after learning new information, as if the brain is processing and storing what was learned. Some researchers have found connections between spindle activity and subsequent dream content, suggesting that the brain's memory processing work during lighter sleep stages influences the dreams that emerge during REM. The different stages of sleep may work together, each contributing its part to the overnight processing of memories and emotions. Research has shown that what you do just before sleep influences dream content. People asked to play video games often dream about those games. Those who spend hours studying often dream about study material. This effect extends beyond activities to emotional states. Falling asleep while anxious may increase negative dream content. Falling asleep in a peaceful state may promote more pleasant dreams. The doorway between waking and sleeping remains open, carrying the flavors and concerns of the waking hours into the realm of dreams. You're still here, still awake, still drifting with us through these stories. Take a slow breath. Notice how your body feels a little lighter now, as if the weight of the day has loosened its grip just slightly. We're exploring the dreaming mind together, you and I and everyone listening in the quiet dark, wandering through mysteries that visit us each night. There's no rush, no destination, just the gentle momentum of curiosity carrying us forward. Let's continue. Dreams may serve an important function in threat rehearsal. The threat simulation theory proposes that dreams evolve to allow us to practice responses to dangerous situations without actual risk. In dreams, we face predators, falls, and social threats, rehearsing escape and coping strategies. This would explain why negative emotions appear more frequently in dreams than positive ones. Evolution may have prioritized dreams that prepared us for danger rather than entertained us with pleasure. The nightmares that disturb your sleep might be ancient training programs, preparing your responses for challenges you may never actually face. The moment of sleep onset, called hypnagogia, often produces unusual experiences. Visual images may appear spontaneously as you drift towards sleep. Some people hear voices, music, or their name being called. Bodily sensations can shift and distort. The hypnagogic state represents a transition between waking consciousness and dreaming, sharing features of both. Creative thinkers throughout history have reported insights arising from this twilight state. Some deliberately cultivated it by napping with an object in hand that would fall and wake them as they began to drift off. Dreams often feature characters whose identities feel uncertain or fluid. You might know that a dream figure is your mother even though she looks nothing like your mother. Characters may shift from one person to another mid-dream. This identity fluidity reflects how the dreaming brain processes recognition. During waking perception, multiple brain systems work together to identify people by face, voice, and context. During dreaming, these systems may provide conflicting information that the dream narrative simply accepts. Identity becomes a feeling rather than a fact. Some people experience sleep paralysis, a state in which they wake mentally while their body remains immobilized. This occurs when the normal muscle paralysis of REM sleep persists into waking consciousness. The experience can feel unsettling, especially when accompanied by hypnagogic imagery. Throughout history, sleep paralysis experiences have been interpreted as encounters with demons, aliens, or supernatural presences. Understanding the neurological basis of this experience can reduce its frightening quality. Sleep paralysis is simply a timing mismatch, the body waking more slowly than the mind. Dream journaling over time reveals patterns that might otherwise go unnoticed. Common themes emerge, recurring symbols appear, and connections to waking life become clearer. Long-term dream journals have provided valuable data for researchers and personal insight for dreamers. Some people discover that certain types of events reliably produce certain types of dreams. Others notice cycles in dream content that follow patterns in their waking lives. The dreams that feel random and disconnected often reveal their connections when viewed over months or years. The brain chemicals that dominate during REM sleep differ markedly from those present during waking. Acetylcholine, which promotes brain activation, reaches levels as high as during alert wakefulness. But norepinephrine and serotonin, which contribute to logical thinking and mood stability, drop to their lowest points. This unique neurochemical environment may explain many characteristics of dreams. The absence of stress hormones might allow emotional processing without overwhelming anxiety. The high acetylcholine might drive the vivid imagery. The sleeping brain operates in a chemical state that exists at no other time. Shared dreams, in which two people report having the same or very similar dreams, have been reported throughout human history, though they remain scientifically unexplained. Most researchers attribute such reports to coincidence, suggestion, or selective memory rather than any genuine sharing of dream experiences. People close to each other often share concerns and experiences that might produce similar dreams independently. Yet the persistence of shared dream reports across cultures raises questions that current science cannot fully answer. The nature of consciousness during sleep remains mysterious enough to leave room for wonder. False awakenings occur when you dream that you have woken up and begun your normal routine, only to discover that you are still dreaming. Some people experience chains of false awakenings, waking repeatedly within a dream without ever reaching true waking. These dreams often reproduce bedroom environments in remarkable detail, making the transition between dreaming and waking especially confusing. False awakenings demonstrate the brain's ability to construct convincing simulations of ordinary reality, not just fantastic adventures, but the mundane experience of waking and rising from bed. Dreams rarely include reading or performing complex mathematical calculations, activities that require concentrated logical processing. When text appears in dreams, it often shifts and changes when looked at again. Clocks show impossible times, numbers refuse to add correctly. These failures reflect the reduced activity in prefrontal brain regions during REM sleep. The brain systems that support careful sequential logical processing are not fully available to the dreaming mind. Instead, dreams rely on the brain's capacity for imagery, emotion, and narrative, creating experiences that feel real without requiring logical consistency. Halfway through our journey, a pattern emerges. Dreams are not random noise, but structured experiences that reflect how the sleeping brain processes memories, emotions, and concerns. They emerge from a unique neurological state that enhances creativity while suspending critical judgment. Dreams feel real because they activate the same brain systems as real perception. They feel meaningful because they draw from our genuine concerns and experiences. Whether dreams serve specific functions or are simply byproducts of sleep processes, they offer a window into the remarkable workings of the human mind. And imagine, even when everything seems still, your mind is always moving through invisible landscapes. The space inside your skull holds entire universes, worlds that exist only for you, only for this moment. Think about the dreams you've already had tonight. Perhaps before this video began, dreams you don't remember. They came and went like clouds passing through a night sky. Let go of needing to hold anything. Dreams teach us that experience can be complete even when it fades and leaves no trace. This moment, too, will become part of your dreaming material. Some gentle version of this piece may visit you while you sleep. Now we continue the journey. The sleeping brain shows remarkable activity even during dreamless sleep. Slow waves of electrical activity sweep across the cortex during deep non-REM sleep, coordinating the firing of millions of neurons. These waves may serve to strengthen important neural connections while weakening unneeded ones. Sleep clears metabolic waste products that accumulate during waking hours. Even without dreams, sleep performs essential maintenance that keeps the brain functioning properly. The dreaming periods punctuate this deeper work, but the quiet periods between dreams matter just as much. Some people experience precognitive dreams, feeling that dreams have predicted future events. While no scientific evidence supports actual precognition, several factors might create this impression. Dreams often contain vague scenarios that can match many possible outcomes. Memory can reshape dreams to better fit subsequent events. We remember hits and forget misses. The sheer number of dreams we have makes occasional coincidences inevitable. Yet for the dreamer, the experience of seeming to foresee the future can feel compelling and mysterious. External stimuli can be incorporated into dreams without waking the sleeper. A ringing phone might become a school bell. Water dripping might become rain. The sleeping brain monitors the environment and weaves relevant signals into the ongoing dream narrative. This incorporation usually maintains dream coherence, translating external events into dream-appropriate forms. The brain continues to protect sleep while remaining alert enough to respond to genuinely important signals. A sleeping parent might incorporate soft noises into dreams but wake instantly to a baby's cry. Depression and anxiety often manifest in dreams through characteristic patterns. Depressed individuals frequently report dreams with themes of loss, failure, and helplessness. Anxious dreamers often face threats and pressures in their dreams. The emotional tone of waking life colors the emotional tone of dreams. Sometimes dream content shifts before waking symptoms, as if the sleeping mind perceives changes that consciousness hasn't yet registered. Paying attention to dream themes may offer early warning signs of shifting emotional states. The brain's visual processing during dreams differs subtly from waking vision. Dream images often lack the sharp focus of waking sight. Peripheral vision may be absent or inconsistent. Colors sometimes appear more or less vivid than in real life. These differences reflect the fact that dream vision is constructed internally rather than derived from actual light hitting the retina. The brain approximates visual experience, creating something convincing enough to sustain the dream narrative without matching real vision perfectly. Some researchers study dream content by analyzing thousands of dream reports systematically. This quantitative approach has revealed consistent patterns across large populations. Familiar people appear more often than strangers. Locations tend to be realistic settings rather than fantastic ones. Negative emotions slightly outnumber positive ones. Men and women show subtle but consistent differences in dream content. These patterns emerge clearly only when many dreams are analyzed together, revealing structures invisible in any single dream experience. Learning consolidation during sleep may involve replay of experiences at accelerated speeds. Studies in rats have shown that neural patterns associated with maze learning replay during sleep much faster than they occurred during actual learning. This compressed replay might allow the brain to review and strengthen memories efficiently. Human brain imaging suggests similar accelerated processing during sleep. The dreams that incorporate learning experiences may represent the subjective experience of this rapid memory processing. Dreams during illness often take on particular qualities. Fevers can intensify dreams and make them more bizarre or disturbing. Physical discomfort may appear symbolically in dream content. Some diseases affect the brain directly, altering dream experiences in characteristic ways. Parkinson's disease, for example, is sometimes preceded by years of vivid dreams and REM sleep behavior disorder. The dreaming brain reflects the state of the body, changing when illness changes the conditions of sleep. The sleep disorder narcolepsy produces unusual dream experiences. People with narcolepsy may enter REM sleep immediately upon falling asleep, experiencing dreams at sleep onset rather than after the usual 90-minute delay. They may also experience intrusions of dream imagery into waking consciousness. Narcolepsy reveals that the boundary between waking and dreaming is maintained actively by the brain and can fail in revealing ways. The careful orchestration that normally separates these states becomes visible when it goes awry. Dream emotions often feel more intense than corresponding waking emotions. The fear in a nightmare can feel more terrifying than waking anxiety. The joy in a pleasant dream can feel more pure than waking happiness. This intensity may result from the brain's altered chemistry during REM sleep, particularly the suppression of brain systems that normally moderate emotional responses. Dreams offer an experience of raw emotion, unfiltered by the cognitive controls that usually shape our feelings into more manageable forms. Some people report experiencing pain in dreams, though this is less common than other sensations. When dream pain occurs, it may or may not reflect actual physical pain in the sleeping body. The brain can generate the experience of pain internally, just as it generates visual or auditory experiences without external input. Dream pain demonstrates that all sensations, even unpleasant ones, are fundamentally brain constructions that can occur with or without corresponding external stimuli. The phenomenon of dream incorporation takes time to unfold. Recent experiences rarely appear in dreams immediately. More commonly, elements from 1 to 7 days prior show up in dream content, a pattern researchers call the dream lag effect. This delay may reflect the time needed for memories to be processed and consolidated. The events of today will likely visit your dreams not tonight but in the coming week, transformed by the processes of memory. People who lose the ability to dream due to brain damage often don't notice the loss. Dreams are so ephemeral, so easily forgotten, that their absence may go unremarked. Some patients with specific brain lesions report that they no longer dream, though they continue to show normal REM sleep activity. This suggests that the experience of dreaming requires specific brain regions beyond those needed for REM sleep itself. Dreaming is something the brain does, and specific parts of the brain are necessary for it. Dreams sometimes solve problems that waking thought could not. Researchers have documented cases where people struggled with puzzles during the day only to dream of solutions that worked. The sleeping brain may approach problems differently, freed from the assumptions and constraints that limit waking thought. Not all dream solutions are valid, but the loosened associations of dreaming occasionally produce insights that sequential logical thought would never reach. The neurotransmitter dopamine, involved in motivation and reward, shows altered activity during REM sleep that may contribute to dream experiences. Dopamine is associated with the experience of pleasure and the anticipation of reward. Its activity during REM might contribute to the emotional intensity and motivational themes common in dreams. The chemistry of dreaming involves multiple neurotransmitter systems interacting in ways scientists are still working to understand. Some meditation practices are specifically designed to influence dreams. Tibetan dream yoga traditions aim to maintain awareness through the transition from waking to sleeping, cultivating lucidity in dreams. Long-term meditators often report increased dream recall and more frequent lucid dreams. The skills developed in waking meditation, particularly metacognitive awareness, seem to transfer to sleep. Training the mind during waking hours may change what happens when that mind enters dreams. Dreams sometimes occur during anesthesia, though they differ from normal dreams. Patients occasionally report experiences that seem dreamlike, though the brain states involved differ from natural sleep. Some anesthetic drugs suppress all mental activity. Others produce states that share features with dreaming. The study of anesthesia dreams contributes to understanding consciousness itself, revealing what brain activities are necessary for any subjective experience to occur. The sense of self in dreams ranges from ordinary to deeply transformed. In most dreams, you experience events from your normal perspective, with your usual sense of identity. But some dreams involve being someone else entirely, or observing scenes without a clearly defined self. Some dreamers report experiences of expanded or cosmic consciousness, feeling merged with everything rather than localized in a single body. Dreams explore the boundaries of selfhood that waking experience usually takes for granted. Keeping regular sleep schedules supports healthy dream patterns. Irregular sleep tends to fragment REM sleep and may produce less coherent or less memorable dreams. The brain's circadian rhythms anticipate regular sleep times, preparing the conditions for effective dreaming. Shift workers and others with variable schedules often report disrupted dreams along with their disrupted sleep. The dreaming mind, like the waking mind, functions best within predictable rhythms. Dreams may contribute to emotional healing after loss. Bereaved individuals sometimes dream of deceased loved ones, and these dreams often provide comfort. Dreams can offer experiences of reunion, forgiveness, or closure that waking life cannot provide. The sleeping mind continues to process relationships even after death has ended them in waking reality. These visitation dreams, whether understood as spiritual experiences or psychological processes, often bring peace to those who have them. The experience of forgetting dreams immediately upon waking suggests something about how memory works. The shift from sleeping to waking brain states may prevent the transfer of dream memories into long-term storage. It's as if dreams are written in a kind of ink that evaporates in daylight. This forgetting may be functional rather than accidental. If we remembered every dream perfectly, we might have difficulty distinguishing dream memories from real ones. Some dreams feel prophetic not because they predict the future, but because they accurately reflect the present. Dreams often register changes in health, relationships, or situations before conscious awareness catches up. The sleeping mind may notice patterns that the busy waking mind overlooks. When a dream seems to predict an event, it may simply have recognized something that was already happening but had not yet entered conscious awareness. The universality of dreaming across human cultures and throughout recorded history suggests that dreams serve fundamental purposes. Every human society has stories about dreams, interpretations of their meanings, and practices surrounding their use. This universal interest may reflect the genuine importance of dreaming to human psychological functioning, or it may reflect the inherent fascination of experiences so vivid yet so impossible to share fully with others. Dreams can be deliberately influenced through a practice called dream incubation. By focusing on a question or topic before sleep, many people find that their dreams address that focus. Ancient cultures practiced dream incubation formally, sleeping in temples to receive divine guidance through dreams. Modern research suggests that focused intention before sleep does indeed influence dream content, though the mechanism remains unclear. The waking mind can request, and sometimes the sleeping mind responds. The science of dreams continues to advance. New brain imaging technologies allow researchers to observe the dreaming brain with unprecedented detail. Computational methods can now analyze thousands of dream reports to find patterns invisible to human reviewers. Our understanding of why we dream the way we do deepens with each passing year. Yet dreams retain their mystery, offering experiences that science can describe but never fully capture. The dreaming mind remains partly beyond reach, creative and strange and endlessly surprising. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles, waking and sleeping, sleeping and waking, dreams flowing through the night like tides, your breath rising and falling, all are circles, cycles, endless rhythms, like your heartbeat, a small cycle within the vast rhythm of life. You are part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order, like dreams silently rotating through your sleeping hours. Unhurried, unresisting, simply existing. We're almost there now. Dreams speak in images rather than words. The sleeping brain communicates through symbols, scenes, and feelings rather than the sequential logic of language. This visual, emotional language may be older than spoken language in evolutionary terms. Understanding dreams requires learning to read this different vocabulary, one that speaks to deeper layers of the mind than words can reach. Every dream you remember once existed in its full richness. The fragments that reach waking memory are remnants of experiences that felt complete in the moment. Like visitors from another world, dreams arrive fully formed and depart, leaving only traces. The dreams you will never remember were just as real as those you do. The darkness behind your closed eyes becomes a screen for infinite movies. Night after night, year after year, your sleeping brain projects experiences that engage your senses and emotions completely. This creative capacity costs nothing, requires no effort, and functions with or without your attention. It simply is what brains do when freed from the demands of the external world. Sleep and dreams evolved long before humans appeared. Our distant ancestors dreamed. Though we cannot know what their dreams contained, the dreaming brain is an ancient inheritance, shaped by millions of years of evolution to serve purposes we are still discovering. When you dream, you participate in something older than humanity itself. The boundary between sleeping and waking is not a sharp line, but a gradual transition. Consciousness dims slowly rather than switching off. Dreams may begin before full sleep arrives, and their influence lingers after waking. We spend our lives moving back and forth across this soft border, neither fully here nor there during the transitions. Dreams reveal something profound about perception itself. What we experience as solid reality during waking hours is also a mental model, constructed moment by moment from sensory signals. Dreams simply make this constructive process more obvious, creating experiences without external input. In this sense, all of conscious experience is a kind of waking dream, shaped by the brain's interpretive powers. The emotions of dreams do not follow from their events. We can feel profound sadness in a dream without anything sad occurring, or experience joy for no apparent reason. Dreams reveal that emotions are not simply responses to events, but independent experiences that the brain can generate directly. The sleeping mind feels without needing a reason why. Some dreams return us to places we have not visited in years. The sleeping brain stores detailed memories of locations that waking consciousness has forgotten. In dreams, we can walk again through childhood homes, explore schools long demolished, and revisit scenes from decades past. Memory preserves more than we consciously remember. The characters in dreams are created by the dreamer's mind, even when they seem to act independently. The person who surprises you in a dream is a construction of your own brain, saying things your mind invented. Dreams demonstrate the brain's capacity to simulate other minds, to imagine perspectives beyond our own. We dream alone, but populate our dreams with others. Dreams need no interpretation to serve their purposes. Whatever functions dreams perform, they work whether we remember them or not, whether we analyze them or not. The dreaming brain does not wait for permission or require understanding. It simply works through the night, processing and creating according to its own logic. So could dreams change how we understand ourselves? They already have. Dreams show us that consciousness is not a single thing, but a range of states, each with its own character and possibilities. The sleeping self is still the self, experiencing life in its own way, contributing to who we become without our awareness. The strangeness of dreams reveals how strange consciousness itself is, that awareness can exist at all, that the physical brain produces the felt quality of experience, remains deeply mysterious. Dreams are strange because consciousness is strange. They remind us how remarkable it is to experience anything at all. Dreams show us ourselves from angles we cannot see while awake. The concerns we deny, the fears we avoid, the wishes we suppress may all appear in dream form. Dreams do not judge or censor. They simply show what moves beneath the surface of our waking awareness, offering glimpses of the larger self. The forgetting of dreams may protect as much as it obscures. If we carried perfect memories of dream experiences alongside waking memories, distinguishing reality from imagination might become difficult. The fog that erases dreams may serve to keep our sense of reality intact, maintaining the clear boundary between what happened and what was merely dreamed. Dreams have inspired art, music, literature, and scientific discoveries throughout human history. the creative productions of the sleeping mind have enriched waking culture immeasurably. When you dream, you participate in the same creative process that has contributed to human culture since before recorded history. Your dreams belong to the same tradition as every dream ever dreamed. The simplest explanation for dreaming may be that brains dream because that is what brains do. Just as hearts beat and lungs breathe, brains dream. Seeking a single purpose for dreams may miss the point. Dreaming might simply be a natural expression of brain activity during sleep, as fundamental and purposeful as breathing. Every night offers a fresh beginning. Whatever dreams visited last night have faded. Tonight's dreams wait in potential, not yet dreamed, not yet imagined. The sleeping brain approaches each night with creative resources ready to generate new experiences. Nothing is determined, everything is possible. Dreams connect us to the unconscious mind that normally operates beyond awareness. In dreams, we encounter parts of ourselves that waking consciousness cannot directly access. This meeting between conscious and unconscious may be one of dreaming's most valuable gifts, a nightly opportunity for the different aspects of mind to communicate. The science of dreams has revealed much, but mystery remains. We know where dreams come from in the brain, but not fully why they take the forms they do. We know that dreaming serves important functions, but not precisely how. Dreams keep their secrets even as science illuminates their boundaries. Your dreams tonight will be uniquely yours. No one else will ever dream exactly what you dream. Each dream is an original creation, never to be repeated. The sleeping mind generates endless novelty, crafting experiences that have never existed before and will never exist again. Dreams are the most private art form. Dreams ask nothing of us. They come whether we welcome them or not. They depart whether we try to hold them or not. They expect no gratitude and offer no demands. Dreams are perhaps the purest gift the mind gives to itself, requiring nothing in return. Sleep approaches now like a gentle tide. The dreams that will visit tonight are gathering somewhere in your mind, waiting for sleep to set them free. You don't need to prepare for them or call them forward. They know how to arrive when the time is right. The brain that has listened to these facts will carry them into sleep. Some fragment may appear in tonight's dreams, transformed into image and feeling, or nothing may appear. Either way, the sleeping mind will do its quiet work, processing whatever the day has brought. Dreams teach us that letting go is possible. Every dream is released upon waking. Nothing is held forever. The grasping mind can rest, knowing that release is natural and complete. What must be remembered will be remembered. What must be released will dissolve like morning mist. And so we return to where we began. Why do we dream the way we do? Because the sleeping brain is creative, emotional, visual, and free from the constraints of logic. Because evolution shaped dreaming across millions of years. Because memory and emotion need time to process. Because consciousness, that remarkable phenomenon, takes different forms throughout the day and night. We dream the way we do because we are human, and dreaming is part of what being human means. And so, our quiet journey through the dreaming mind comes to a gentle close. We've traveled from the electrical storms of REM sleep to the universal themes that visit sleepers around the world, discovering along the way that dreams are not random noise but structured experiences emerging from your remarkable brain. From the limbic system painting emotions onto nighttime visions, to the prefrontal cortex stepping aside to let imagination roam, we've glimpsed how dreaming is both ancient gift and nightly renewal. Dreams remind us that consciousness is vast and varied. Much of what our minds do happens in silence, in sleep, in spaces we cannot directly observe. They teach us that we are creative beings, generating entire worlds while we rest. Without dreams, something essential would be missing. By pausing to notice, we glimpse the extraordinary in the ordinary act of sleeping. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about unity of every thought, every memory, every emotion in your mind. You're not separate parts. You're a whole being, moving between states of awareness. Think about consciousness itself, yours, mine, everyone listening, all awareness everywhere, perhaps all connected in ways we don't yet understand. You're not alone in the universe of minds. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. Prepare for deep sleep, no boundaries left, only peace. If this thoughtful exploration of dreams made you feel less alone in the mysterious night, whisper it forward to someone awake tonight. It may bring comfort to one more wandering consciousness, one sleepy soul at a time. But there's no need to do anything now, nothing at all. You've traveled far tonight, farther than most journeys take you. You can allow these thoughts of dreams to fade now, like the dreams themselves fade each morning, leaving only the quietest calm behind. Let your breathing deepen, let your body feel heavier, as if gravity itself is gently holding you. If sleep comes, let it carry you like a slow river, smoothly, inevitably, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, your dreams will still be there. The sleeping mind will still weave its nightly creations. But tonight belongs to stillness. Rest well, gentle dreamer. And remember, the dreams that visit you tonight are gifts from the deepest parts of yourself. Where science meets sleep, dream deeper with bedtime science. Good night.